Okay, this is our last part of the polynomial and rational inequalities. This is actually a rational inequality. 5x minus 2 over 3x plus 6, then we'll know that when that's greater than 1. Now, actually, this is a rational function with a horizontal asymptote of 5/3, and they want to know when that's greater than 1. Okay, so you could draw this whole thing and put a horizontal dotted line at 1 and see where the graph is above 1. There's a lot. That's a lot involved there, and that's really more than what we really need to do. Okay. Now, there's a couple of ways to do this problem, though. One way to do this problem is kind of the way we always have done it, set it greater than 0 because we want to know what's above or below the x-axis. And the problem with that is you'd have to move the 1 over, get a common denominator, and reset the fraction up as greater than 0 like the previous problem I had in the last part that I had. So in other words, you set 5x minus 2 over 3x plus 6 minus 1 greater than 0. And this is the technique that I have usually taught it, and I'll go ahead and show you how it works with this technique. But the next way I'm going to show you, you might want to use that technique there because a lot of people have trouble with this technique right here. This is the way I've always taught it because it makes more sense to me. And but obviously, to some people it doesn't make sense to. So I'm going to give you another situation, another way to do the same problem. But find your niche, find the one that works for you. Okay. This way may be best for you, and if you like it, ignore my second technique, and vice versa. Okay, but I'm going to give you 2 ways to do it. So what you would do is you would get a common denominator, which is 3x plus 6 over 3x plus 6. That's really 1. And then 5x minus 3x is 2x. Negative 2 minus 6 is negative 8 over 3x plus 6, okay? And that's greater than 0. Now you do this exactly what we did in the last part now. When is this greater than 0? So top is 0 when x is 4, and the bottom is equal to 0 when x is negative 2. And the horizontal asymptote is 2/3. 2/3 is above the x-axis. And so at the ends, the horizontal asymptote is 2/3. So it's above this way and this way because 2/3 is above the x-axis. And these cross because they have odd degree powers. And so between -2 and 4 is below. So the solution to this problem is on the left side of -2 and on the right side of +4. So the answer is negative infinity to -2 union 4 to infinity. Okay? So that is the solution. You know, like some people say, well, that's easy enough. Well, the problem with it is the greater than 1 part. People will forget to move the 1 over. Okay, and if they do move the 1 over, they don't know what to do at that point. They forget that you have to get a common denominator. So this little part right here is the reason I'm going to try to do it another way here. Is because this is where it kills people. They don't know that from here, this hand to this hand. If they can get to this point, they're usually okay. But getting from there to here is the trouble. And so I'm going to show you another technique on how to do the same exact problem. Okay. So first, you draw your number line like you normally would do. And you're like, well, it's quicker. Well, it kind of is. The first thing you do is figure out what makes the denominator 0, because that's not going to change. The -2 is this point right here. So that's not going to change at -2. And so instead of, you can't just multiply the 3x plus 6 when it's an inequality because you don't know what the value of 3x plus 6. So to find the other intercept, you solve this equation, 5x minus 2 over 3x plus 6 equal to 1, not greater than 1, because now you can move the 3x plus 6 over. So it becomes 5x minus 2 equals 3x plus 6. And then subtract 3x, and that's 2x minus 2 equals 6. And so 2x equals 8 when you add the 2 to the other side. And divided by 2, x equals 8 divided by 2, which is the other number on the other one. So that's 4. Okay? And again, the ends, we're going to be 2/3 on that one. Well, on this one, you can't really tell on this one. So this is the trouble this one has. You can't just say it's 4/3, 5/3 here, because you don't know what the rational function is. So this is one of those problems you might just go ahead and just test points, which is what all the other teachers are doing anyway. So if you test 0, if you put 0 in, and -0 is between -2 and 4, and see if it works or not, well, 5 times 0, 3 times 0 is both 0, so it's -2/6, which is a -1/3, but that's not greater than 1. So that one doesn't work. Okay, and then if you try like -3, put that back in, you get -17 on top, and -3 times 3 is -9, plus 6 is -3, which is positive 17/3, which is greater than 1. So this one is okay. And similarly, if you try a number like 5 and see if 5 works, so you could do this on every one. You could do this on every one of your problems. Test these points, okay, and see if they work or not. If they don't work, X it out. If they do work, circle it, and you know it works. Okay, so you could do this on every one of them. All the other parts that I've done, you could do that as well. And I was just showing the in behavior before because it's a lot faster that way. You don't have to do all these testing because, if you notice when I put the -3 back in, I was sitting there, okay, what, I was trying to do the calculation in my head. And if you don't have much experience with calculating, it can sometimes mess you up. And so -3 works. 5, I would venture to say it would work too. 5 times 5 is 25, minus 2 is 23. And then 3 times 5 is 15, plus 6 is 21. And 23 divided by 21 is barely above 1, but it is. And so 5 works as well. And so the solution is -infinity to -2, union 4 to infinity, just like it was before. So again, whichever part you like, the way you like the best, stick with that technique. Don't switch back and forth with your techniques, because usually you're going to get them confused. Most students will like this technique better. Find the vertical asymptotes and then do the equation to find the other number, and then do 3 test points. This is just one scenario that I would say go ahead and say do it by test points. But otherwise, you can move the 1 over, get to set up your rational function, whether it's above 0, whether it's below 0, and so 4 and -2. But like I said, I showed you 2 ways, and this is kind of in a class of its own. All the other problems that I've done, all the other steps, they work pretty much differently than this one. So because of the 1, so that's the issue that you're creating there. So, but this concludes all the parts of the polynomial and rational inequalities. There's like 5 parts to this series. So enjoy.